So the scale of the landmass that's draining into Lough Neagh just shows us really how big its influence is, because the aquatic ecosystem, which is the whole catchment, it's the loch itself, and downstream to the coast, is all connected. So that aquatic system is absolutely key to preserving our agriculture, our quality of life, and our environment. And that's something that's fairly significant at a societal level. Well, blue-green algae are an absolutely fantastic part of our plankton community. So our plankton in the loch is made up of microscopic algae, of bacteria, and of cyanobacteria, which are the blue-green algae. They're a very specific organism. So essentially they are a bacteria and not a plant, but their unique thing is that they can photosynthesize. So they produce oxygen, they can fix nitrogen. Indeed, they were one of the organisms that actually created our early atmosphere. Both algae and the cyanobacteria, the blue-green algae, are key components of our plankton. So they're part of the ecosystem, and when they're in the right balance, they're an essential part. They provide food for the rest of the ecosystem, for the fish, and of course to the birds. So they're very important, and the cyanobacteria in Lough Neagh, of course, typically would have been species that favoured lower light conditions and lived sort of under the surface of the water. But then the more recent events have shown a transition to this species that's very buoyant and floats to the top and causes a very visible bloom. So blooms have probably been happening for decades or since time began, but recently the species have changed, which means it's a very visible surface scum that forms. There's been a lot of research, and this has been going on probably from the 60s, when the first bad blooms occurred in Lough Neagh, and AFBI have maintained that research programme right the way through. So seeing the change in conditions that's led up to this has been something that's been of great interest, and we've been analysing quite closely. So 2023 we had quite an unusual sort of very warm, still spell of weather. So that allowed the lake to really warm up and become very calm and not mix as much as it normally would. So those conditions, along with what was building up to that, which was the water was becoming clearer and the water's gradually warming through climate change, meant that the key species in the loch changed to a species called Microcystis and another called Anabaena. And those species really like calm, still conditions. So the food was there, the light was there, the temperature was there, everything came together, and we had this massive bloom occurring. This type of bloom is by no means unique to Lough Neagh, and there's experience from all around the world of where Microcystis and Anabaena and other species of cyanobacteria form these toxin-producing scums on the lake. So it's a result quite often of eutrophic pressure, so nutrient enrichment, and it's a fairly well-known phenomenon. Lough Neagh is particularly acute because, of course, it's the mixing bowl where a lot of catchments that are managed independently all end up, and all of these nutrients have ended up there. And for decades of nutrient enrichment, the sediments are now so heavily enriched as well. Even if we turn off the taps up the rivers, we've got a great stock of nutrients within the loch. And the concentration of the biomass is now starting to be seen in what would be relatively low quality and unavailable scums associated with these cyanobacterial blooms. So there's a number of elements of water quality that are of concern. AFBI have also been studying some of what we call emerging contaminants, so pharmaceuticals and derivatives of that, to see if those are also part of the pressures. And those are, I suppose, elements of water quality and environmental quality that are driving what is an ecological outcome, as in a very poor ecology here. I think it's important to recognise that we want to return to a good ecological outcome with a robust and resilient ecosystem. So that always has to be our target. So not just the chemical metrics of so many tons of phosphorus or reducing this or reducing that. We want to get to a status where we've got a good ecological integrity.
Since the emergence of the blue-green algal blooms in Lough Neagh, there's been a ramping up of research focus on Lough Neagh here at Queen's. And so we have a large raft of research going on. I myself did a lot of the early study looking at satellite imagery, the extent of the algal blooms in 2023-24. We took water samples and we looked at the density of the algae, the toxins it produces, other bacteria in the water. And then more recently, after describing what has happened in those early algal blooms, we now have a fleet of PhD students who will be focusing on looking historically back using satellite imagery to put the recent events into a historical context. We have another student who will be looking at ecological networks within the loch. We have another student who will be looking at molecular genetics as well. And then we have a number of postdocs that are working on modeling the ecosystem within the loch. And we also then are looking at potential remediation and solutions. So we have a DERA grant where we're trying to develop a natural biocontrol agent to reduce algae in the spring so it doesn't become such a problem in the summer. So there's an awful lot going on at the moment, and it's really nice to see that focus have been established over the last 24 months. When this algae blows ashore and it begins to decompose, what our analysis showed was that that sludge contains a lot of very unpleasant bacteria, Clostridium, E. coli, Salmonella, things that will make you ill potentially. And these come from gastrointestinal tracts. So they come from livestock runoff and human wastewater treatment works getting into the loch, and then they're proliferating and they're using the algae as a food source around the edge of the loch. The other problem with this algae is that it produces toxins, microtoxins, and these are quite unpleasant for human beings and other mammals to ingest. They can make us sick and they can even cause death in very high concentrations. So these toxins we found, there was about 11 different toxins in the lake, and some of them were exceeding the World Health Organization recreational exposure limit. So this, what our research showed is that those early blooms are really representing a public and environmental health hazard. So the problems that have caused the blue-green algal blooms recently are a combination of nutrient enrichment, runoff from agriculture and wastewater treatment works, climate change, the water is warmer than it was 2 decades ago, and also non-native invasive species. So we have zebra mussels, which come from southeastern Europe and Asia, that have invaded the loch, and they change the ecology of the loch. The interaction of these three things have really brought to the fore the conditions that have allowed these algae to proliferate. So in addition to potential technological and engineering solutions, I think it's very important to recognize the potential value of what we call nature-based solutions. So nature can do an awful lot of the remediation itself if we help it along. So one of the problems is that all of our mountains, the Spurins, the Antrim mountains, where rainwater is running off and getting into the rivers and getting into Lough Neagh, are entirely denuded. We have no upland forests left. So for example, reforestation would help capture water, hold it back, and prevent a lot of the runoff getting into our rivers. Similarly, we have a lot of peat bogs, and those have historically been exploited for turf, and as a result they've been drained, and we have a lot of peat erosion, so dark material getting into the rivers and enriching our rivers. So again, things like re-wetting our wetlands, ensuring that there are big sponges that hold on to that water and prevent it getting into the river would be extremely useful. Using things like drainage swales, so boggy areas planted with willow trees or reeds would help absorb those nutrients before they get to the river. So a whole range of nature-based solutions could be implemented across the country, including re-establishing what we call riparian corridors. So these are strips of land a few meters either side of the river, which is allowed to vegetate, and they basically act like a big sieve. They catch all of the nutrients before they run off the fields and they get into the water. Really simple, low-tech, low-cost solutions that would help in the long term remediating this over the next 30, 40 years.